So, quick introduction to bars and how we start. So, bars comes from an old and outdated, well, I wouldn't quite call it outdated, but it's an old method of 4C recognition. So, there's normal recognition, there's the BU recognition, which was the first way you could predict which 4C case you could get, and then there is also BDFDB. Now, bars is just another way, essentially, to recognize what 4C case you have. And you do it by paying attention to where both the U layer edges are and the D layer edges. And you want to form bars. So you can make a bar of all yellow here and a bar of all white just by doing that. And then you can see this bar is the wrong way around. So we flip it and that's solved. So an old-ish recognition system, maybe not the greatest. Works for bars, works for dots as well, because we want to form a couple of bars and then make sure those bars are the right way around. So nice and simple, but this forms the basis of bars. I'm sure many of you already know this, but if you don't, I would really encourage you to try and get your head around it, because this is what we're going to be building off for the rest of the video. So, what do I mean when I say layers of abstraction? Well, what I mean by this is that you can take an initial concept from one part of the solve and try to apply it to another. So in CFOP, one idea is edge orientation. And when you can apply this to F2L, for example. So say here, what you could do is just do a normal insert and then be left with this OLL case, which admittedly is quite nice, but we'll get to that. So instead of just inserting like this, what we could do is go for EO and just do a sledgehammer, and we end up with nice oriented edges on top. Now, while admittedly this case is nicer, there are many cases where it would actually be nicer just to go straight into here and use the COLL case, or the just the OCLL case, which tend to be faster than OLLs on average. So while it's not a concrete thing, in general, it's nicer to have oriented edges on last layer than it is to not. So you're essentially rolling weighted dice. Odds are this will end up nicer for you, but it's not a guarantee. So when I say layers of abstraction, I mean you take a concept from one part of the solve, so in this case EO in last layer, and apply it to, say, last slot, and making an educated guess as to whether or not the resulting case will be nicer than if you don't use that trick. And this is something you can apply to LSE with the bars method, because you want, instead of just looking at using it to predict 4C, you can try and force nice 4C cases. Like here, you can, instead of just predict OLL, you can try and force yourself to have nice OLL cases. So at this point, you might have just sat through those last two things thinking, okay, yeah, but I already knew this, so why is it any more useful than anything? So if we take the first layer of abstraction we can have, so we can use these ideas to build up a tree, more or less. So you build up a set of rules of thumb which we can use all through LSE to try and give us nice 4C cases. Ideally a skip. So if we go one level down from just using it for 4C, how might we take this idea and abstract upon it to give us a nice 4C case after we've done EO? Well, the goal of it is we want to make a lot of bars. 3 bars really. The ULUR bar, the UFUB bar, and the DFDB bar. So, that's the first thing we might think. Well, ideally we want as many bars as possible. So what we can do is we find a way to before going into 4C, make as many bars as possible. So the first thing I see here is that we have this pair, which pairs with here. And then we'll end up with all the other edges that we want on the same slice after we do a U move. So here, these two have already been paired, so I just leave them in ULUR, and then we just want to make as many bars here as possible. So what we do is we insert, pair them up, and surprise, it's given us a nice 4C case. So, just to reiterate one more time, we want to give ourselves a nice 4C case. So that our first trick we might be able to use to do that is to try and get 3 bars before we start 4C. Now, it's worth noting that this doesn't always work, and there are cases where you might be better off not using it. But as I said, rule of thumb, usually nicer. So, these two are already paired up. So what we want to do is we want to pair the rest of them up. So put them all on the same slice, orient it, and there we go. 4C skip, more or less. UFUB, same sort of thing. So, one more example. Remember, we just want to make as many bars as possible. And my computer just turned off. Okay, we want to make as many bars as possible. Here we have this, which looks nice and promising to start with, because all we need to do is U2, and we pair them up already. And here we want to pair these two ones up, so put them all on the same slice, insert, and there we go. So that's the first trick we could use. So we just went up one layer of abstraction, and we just had a look at one nice way that we could force a nice 4C case. Okay, so you saw the first example of abstraction in LSE, of going up one level, working out how to force nice 4C cases. But clearly that's not all you're going to be able to do with it. If it was, I wouldn't be talking about this, because it's just a tiny little trick that's not especially useful. So, let's try and find another rule. So you can find multiple rules for the same layer of abstraction. So, what we might think is that in general, we might also want to skip dots. So we can do this by making sure that the yellow center always ends up between the two yellow edges. So, what we can do is we can insert this to try and ensure that we'll have these two paired up nicely. If I can remember. Yep. So here, and we have the yellow center between them before we insert, and that's actually given us more or less a 4C skip. So, how might we insert this so that eventually we'll likely get a yellow sticker between the two centers? Well, you can pair it up like this, and then once we insert here, then it's sort of a skip. That was not the most efficient way to do that, I will admit it. But essentially, one rule is that we want to force a yellow center between the two edges before going into 4C. And that will, a lot of the time, give us a nicer case they're not. So, the idea, the real core root idea of the bars method for LSE is that you can go from one layer and you can abstract it up another layer. You find as many tricks in that layer as you can. So, we took a recognition method for 4C, and then we abstracted this up to after all the edges are oriented, and we found as many tricks as we possibly can there. Now, you might be thinking, can we take this one layer up? And yes, of course we can. And we're going to find as many tricks as we can with just the arrow, which is where I personally start thinking about all of these tricks. Now at this point you might be thinking, oh yes, it's all very well having all these tricks, but it's not especially useful because you've got so many tricks that it's hard to look for all of them. Well, you don't need to look for all of them. You just need to use the ones that you spot. So, depending on where you start spotting them, this is where the idea of a tree comes in. You start with the most general, broad concepts, and you just get more and more specific each time. So if you spot at the broadest idea, you'll have the most efficient LSE, at least in theory on average. Again, we're just rolling dice. However, you can feel free to ignore that and just go one stage in if it's easier, and then work from there. Now, you're essentially working on a tree that you start on with one end, and for each branch you go down, you get more and more specific with your questions. So, I will put in the description this tree that we have here. So, it's just a simple Excel spreadsheet. And we start with this question. So, let's grab a quick LSE scramble. Now, I know this starts. Now, technically you can have more further that way, but I'm not going to go that way because that uses even more EO, and I personally don't actually use it. So what we're going to do instead is start with an arrow case. Now here, as many of you are aware, I'm sure, you can do 4 different types of inserts, or 4 different types of EO. So, when it says here, how many edges will pair up with this, it's just asking, assuming you can pair up as many edges as possible, how many will you get? So, here I have a look at this cube. I see we will actually have 3. So, we follow the branch for 3. Which edges will end up on UF and UD? Well, the ULUR edges will end up, and the DFDB edges. So what we want here is we want here the ULUR and the M prime edge. Will M prime insert ULUR correctly? No, it will end up the wrong way round. So this tells us sorry, too far. We just do an M and continue with misoriented centers. And there, nice short LSE. So, let's do another example. Let's say this time we don't actually spot. We don't actually have a look here. So, what we do instead is we go, that's not a good case, here. So, let's say we just miss it. We forget to have a look at this stage. So, but let's say we notice here we have these 2 edges paired, and only these 2 edges paired. Well, then we know that we're actually on the 1, and it's DFDB. So we end up here, pair them up and place in the U layer. There we go. Are there any solved edges? No. So, what do we want to do then? Is the U center on U? No. Is there an edge opposite to where it should be? Yes. This piece should be here, but is not. So, what do we do? Yes. So we place the edge at UB, so up back, and do... Ooh, did I read the case wrong? Yes. So, place it opposite, and insert. And again, essentially a 4C skip. So I'll put this tree that I've got here in the description, but ideally I'd recommend you go through and make your own version of this, deciding which tricks are useful, which tricks are not. And you can actually, as I said before, go even further back on this. You can start with other EO cases, because this one just starts with the arrow case. So I'll put this in the description. You have a look at it. You feel free to show me your better trees, because this was just one I quickly threw together using the tricks that I use off the top of my head. And there are a couple of other tricks which I use which aren't quite in here, because there are often better ideas that you can have when doing this. But this is the start of my tree. Have a look into it and just have fun experimenting with bars and layers of abstraction. So as you start with one, then you go one layer up, find all the tricks you can do there, decide which are worth it, and do those. Then go one more layer up, decide which are worth it, do it there, and so on and so on. In theory, you can probably take this all the way down to last pair, but at that time your tree would be so gigantic, I don't really know how you could control it all that easily. But that's it for now. If you have any more questions, I will try to answer them, and if you feel it's necessary, feel free to message me, and I will try to clarify anything I said in this video. So that's it for now. I will see you guys later.